The specifics of an instrument approach, such as altitudes, headings, descent angles, and missed approach procedures, may vary widely from one airport to another. Understanding the fundamental elements of an approach allows you to effectively plan and execute individual charted procedures. Your planning should begin with the pre-flight review of the approach procedures for your destination, and, if applicable, the alternate airport. This will ease some of your workload later when flying the approach. Your in-flight review typically begins as you near your destination. The type of approach to expect is provided by a controller or is broadcast on ATIS.
Warrior 147, turn right heading 160, maintain 3,500, expect ILS runway 19er left.
Roger, Warrior 147, turning right to 160, maintaining 3,500, we'll expect ILS runway 19er left.
Now that you know which approach to expect, you can concentrate your in-flight review on the specific chart. Briefing strip charts provide an easy way to quickly identify the primary items during this chart review. Make sure you have the correct chart by verifying that the heading matches the procedure you're about to fly. Use the communications row to review and set the necessary frequencies you'll use throughout the approach. Use the information in the next set of rows to tune and identify the primary navigation aid, and to review the final approach course, the appropriate altitudes, and the missed approach procedure. Also check the procedural and equipment notes, and the MSA information. Next, you'll want to review the plan view to familiarize yourself with the procedural tracks, nav aids, and headings. The profile view shows the appropriate altitudes for the approach, as well as the headings and fixes along the approach course. Check the conversion table to determine descent rate information. Also, note the appropriate time to the missed approach point in case you must fly a localizer approach due to an equipment malfunction. In this section, review the approach lighting so you know what to expect when you see the runway environment. Should a missed approach become necessary, this portion of the chart provides a quick reference to the initial up and out maneuver. Finally, review the minimum section to determine the minimum altitude and visibility for the approach. The pre-flight and in-flight review of the approach helps to reduce your workload during the actual approach. It also reinforces where to find the information quickly if needed. Now let's take a look at some of the common procedures used to fly an approach. One of these is the use of radar vectors to align your aircraft with the final approach course.
Phoenix approach, Cessna 241, leaving 12,000 for 10,000.
Cessna 241, report Arlen.
Phoenix approach, Cessna 241 at Arlen.
Cessna 241, turn left heading 055, maintain 5,000 until established on the localizer. Cleared for the ILS runway 7 left approach. Contact Phoenix Tower at Reno on 120.9er.
This clearance includes 4 key elements. They are the assigned heading, the assigned altitude, a clearance for the approach, and the instructions for when to change frequencies. Normally, the final heading assignment allows you to intercept the final approach course in sufficient time to establish yourself on the course prior to the final approach fix. Maintaining the altitude assigned by the controller is very important. Controllers assign altitudes that are at or above the minimum vectoring altitude, which provides both obstacle and terrain clearance. Do not descend from this altitude until you are established on the final approach course. Your clearance for the approach means you are expected to intercept the final approach course and fly the approach as charted without a further clearance. However, at a tower-controlled airport, this is not a clearance to land from the approach. Now let's turn our attention to some of the unique aspects of non-radar approach procedures. Without radar assistance, you must follow the charted procedure to align the aircraft with the final approach course. In some cases, your direction of arrival allows you to intercept the final approach course and proceed with a straight-in approach. When this occurs, the chart indicates no PT along the route. At other times, you must execute a procedure turn or course reversal to align your aircraft with the final approach course. The most common procedure turn depicted on approach charts is the one shown here. When this symbol is shown, the method you choose for the course reversal is optional. However, no matter what procedure you use, you must remain within the protected airspace allotted for the procedure and fly the reversal on the same side of the course as it is charted. The method of course reversal for some procedure turns is not optional. When a procedural track is charted, such as this teardrop or this holding pattern, you must fly the procedure exactly as shown. Another important aspect of an instrument approach procedure is whether you can make a straight-in landing or whether you must circle to land. If a circling maneuver is required to align the aircraft with the active runway, there are several issues you must keep in mind. First, you need to know which category you will use for the approach. Remember, if you use a higher than normal approach speed, you must use the minimums for the higher category. Using the appropriate category will ensure you remain within the protected obstacle clearance area defined by the FAA. For example, the protected area for a Category A aircraft is a 1.3 nautical mile arc measured from the end of each usable runway. It also includes the tangent areas. The area for Category B aircraft extends out to 1.5 nautical miles. The obstacle clearance area for Category C aircraft extends out to 1.7 nautical miles. And Category D arcs extend to 2.3 nautical miles from the end of each usable runway. The base of each area is the circling minimum descent altitude specified on the approach chart. So you can see that it's very important not only to maintain the minimum altitude while circling, but also to stay within the protected area for your category of aircraft. Do not descend from the MDA until you have the runway environment in sight and your airplane is properly positioned to make a normal descent to the landing runway. Another unique feature of every instrument approach is the missed approach procedure. It is carefully designed to provide adequate obstacle clearance throughout the segment. Although limited visibility is the primary cause of most missed approaches, you can initiate the procedure for a number of reasons, such as not being properly aligned with the approach course, or receiving specific instructions from ATC.
Cessna 241, execute missed approach. We have a disabled aircraft on the runway.
Beginning a missed approach before you have arrived at the MAP requires special consideration. For example, let's assume you decide to execute the missed approach between the VOR and the 2.8 DME fix. The charted missed approach procedure calls for a straight-ahead climb to 2,100 feet, then a left turn direct to the Mount Vernon VOR, followed by a hold. However, the missed approach segment does not begin until the missed approach point. Therefore, you must delay the turn until you reach the MAP. There is no restriction on climbing early, but an early turn may not provide the necessary obstacle clearance. Another situation that requires special attention is a missed approach during a circle-to-land maneuver. If you lose sight of the runway during a circling maneuver, the AIM recommends that you make an initial climbing turn toward the landing runway. Once you've landed, you must make sure your IFR flight plan is closed. At an airport with an operating control tower, your flight plan is automatically closed for you. At airports without an operating control tower, you must close your flight plan either by radio contact or through a phone call to the nearest flight service station or ATC facility. The foundation for instrument approach procedures comes from the Federal Aviation Regulations and other official FAA documents, such as the Aeronautical Information Manual. It's important to study these sources frequently to keep the procedural side of your IFR skills in top shape.